All right. Okay. You guys ready?
No.
No. Okay, too bad. All right. So half-angle identities, almost the same type of stuff as my double-angle identities, but instead of actually doing twice whatever my angle is, I do half the angle.
Wow.
Ooh.
Half the work. Half the work. Hallelujah.
I know, right? So, but it just so happened to be twice the work.
No.
All right, so, nope, 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 nope. Here it is.
Oh my God.
God damn it.
Excuse me.
God dang it.
No, come on.
Gosh darn it. Gosh darn it.
Oh.
How about you write it down like I asked you?
That's even better. Pacho, how much would I have to pay you for you to give me a note? I'll get it when I get the notes, right?
Huh?
I'll get that when I get the notes, right?
Yeah, but you can't do any of the work without these formulas.
I can finish 5.5 first anyway.
You know, please. Less negativity. You know, I block out
At least I'm
negativity.
saying
No,
that I'm
block out the
going to
negativity.
finish it
No,
out.
block out the negativity. Who's Fraba?
Haters, Pacho.
I know. Put block them haters.
Pacho, what's your favorite dog breed?
Chug.
Hug?
Chug.
Chihuahua bug? But like, why small dogs? That's like not you. Like I could just.
I had a
could
Chug and
picture
it was
you
the
with a-
smartest dog I've ever met.
Are you sure about that?
Yes.
I don't know.
I have never met a dog as smart as my dog
I
was.
have a dog. Well, not my dog. He's my brother's. He's a boxer, and he's learned how to turn on the lights so he can chase the lights, and he can open the doors both ways. He can open the front door to get out. What kind of dog does that? Basically.
Okay, are you guys ready?
No.
I can't even. Can you draw your chub?
This again. All right, so these are identities I'm going to use, okay? So for everything that we're doing, it's all going to refer back to this. So when we were doing this last time, we were actually either working with the left side or the right side, and you'll see why for this right here. Find the exact value of cosine 15 using half-angle identities for cosine. Okay, so to equal 15, I would get what? What would I use for a half-angle identity?
30.
It's half of 30, isn't it?
Yeah.
That's what we're doing, half of 30. So cosine of 30 over 2, there's my half angle. So in this instance right here, from my formula, my A value is what?
30.
30. Because if you notice, 30 over 2, isn't it? That's what I'm looking for. So my A value here is 30. So it's going to go into this. So I'm going to use plus or minus square root of 1 plus cosine 30 over 2.
How do you know which one to use?
Okay.
I think you just said it.
Yes.
Like I was still.
Okay, so now here's cosine, sine, tangent, and tangent has 3 different versions. Now, you want to try and use tangent, kind of like what we had cosine last time. Which one is actually the easiest to use with the information give you? Okay? If they give you only cosine, you're not going to use this one that has sine, right? Yeah. These two have sine. So if you only have cosine, you can do this. Okay? So depending on what's given to you, you're going to choose one of these other ones.
Yeah.
Okay? You're right, because I'm trying to find cosine. For my problem, I'm trying to find cosine. That's what I said. Find the exact value of cosine 15. Is 30 over 2 15?
Yeah.
Yeah, that's where I was getting at. So 30 over 2 is gives me 15, so I have that. So now, inside my radical, I still have my plus and my minus, my square root of 1 plus. Now, what is the cosine at 30? All over 2. Yes. I don't like a fraction over fraction, so I need to. Oh, you did?
Fraction of what?
Okay, so I'm going to reciprocal of the bottom. Isn't this 2 over 1?
Yeah.
Okay, it's 2 over 1, right? So the inside is going to be. So it's 1 plus rad 3 over 2 times
2. Or 1 over 2.
1 over 2. This is the reciprocal of the bottom, right? All this is in the radical still.
Can you distribute?
When I distribute this, I'm going to have.
Does that just completely get rid of the 2 on the bottom?
No, it's not going to, because this is a. When you multiply fractions, it's straight across.
No, on that.
Yes, this is gone because it's now over here. Dividing by 2 is the same as multiplying by 1/2.
Yeah.
And so therefore, when I distribute, I still got my plus and minus. Square root. As I distribute here, I get 1/2. Right? Plus rad 3 over.
4.
Very good.
And then you get the common
Common denominator. What is my common denominator going to be?
4.
4. So I need to multiply this 1/2 by 2 over 2, right?
Yeah.
So if I multiply that by 2 over 2, I'm going to bring it down here again. So I have my plus and minus still. So I have
2 stays the same.
2 over 4, right? 2 over 4. If I reduce that, that's still my 1/2, right? Plus my rad 3 over 4.
And then you just combine.
Then I can combine, like what we have been doing, plus or minus, radical. So it's going to be 2 plus rad 3 over 4. Okay, so now we're going to go with some algebra skills here
No.
for this. Now, when I have a fraction inside of a radical, I could actually separate the numerator and the denominator into 2 separate radicals. I could separate it into 2 separate radicals. So it could break up at this point right here to still be plus or minus. Square root on top, I would have 2 plus rad 3 over rad 4.
Yay.
See what I did there? So my big radical that had a fraction inside of it, right? You see? Okay, my big radical has a fraction inside. So using a algebra skill, okay, you could actually break this up as a radical of the numerator over a radical of the denominator. So I didn't change the numbers at all. I just said that the radical of top over the radical of bottom. Thank you, I think. All right, so now, is there anything I could do to clean this? What's square root of 4? 2. Does that take care of my radical in the denominator?
Yeah.
Yeah, hey look, that's gone now. So now I just have my plus or minus square root of 2 plus rad 3 all over 2. A radical cannot be on the bottom.
There is one.
So this is the denominator. My denominator is just 2.
Is that
Because the square root of 4 was 2. Is that what?
is it done?
Now it's done.
That was good. That is too much.
So basically, you could square root.
So we just leave this top piece alone.
And just work on the bottom.
Just work on the bottom. Now, it's the same this is equivalent to the same answer as when we did the subtraction. When we did the 45 minus 30. Remember cosine? We used to do, cosine 45 minus 30. That gave me another answer, didn't it? It is equivalent. It is exactly, if I put it in the calculator will give me an exact same decimal as this right here. It's just going to look differently. It's a different method to actually get to the same thing. Make sense?
Yep.
Okay.
Oh no.
That's the line we're
Not really.
on. Isn't that just 45?
Yeah, it's going to be 45, right? My A value in this then would be 45. Okay, whatever you have right here, multiply by 2.
So,
And that's going to tell you what it's a half of. Yeah, so I take this and multiply by 2. So it's going to be the tan of 45 over 2. So I needed to multiply this right here by 2 to get what it's the half of.
but it still wants.
Okay? Yes?
Will this progress into like half of made angles?
Half of what?
Okay, so like if you get a number that's in between two angles, like 45 and 30.
Oh, no, it's not going to be half of that. It's not going to be half of a half or something like that. So it's not going to be like, we're just doing the exact same stuff that we have been doing.
Yeah, but will it progress that way?
No, we're not going to actually get to that point where you have to actually try and figure out the whole ratio for it. You're not. So that's kind of what we're getting at. There's only certain ones that we're using, and that's what we have from our unit circle. Does that make sense? Yeah, so it's not going to be all kinds of weird stuff that is not going to end up on the unit circle. And if it's not on the unit circle, it probably means that it's going to be working it backwards from some way, or using something else, or just simplifying it. Okay, so tan of 45 over 2. So that means I have A, right? Okay, so we know what the A is.
Are we
So-
gonna use that bottom one?
Now, what do you want to use?
You could use the chart.
Do you want to use the one with a
No.
No.
radical?
No.
No radical. Okay, so that means that I don't want to use that one. I could use either one of those.
But why
You
can
can
we
use
use
the
either one?
They're equivalent mathematically. Mathematically, I could go through and show you. Right here, we manipulate the same thing since it's going to be the half angle, right?
Yeah.
And so this gives us one form right here. This is one form of it. Where I go over here, I do the same thing. Okay? But instead of actually writing it out using the half angle, we used the double angle of this. Double angle of this, and then did the same thing. So it's just using different identities that we already have. And just, it comes out to be the exact same thing. So you want to use what you think is going to be easiest. What do you think is going to be easiest? I think it's going to be this one.
I thought it would be.
Sure, you're.
Why do you think that?
Okay, see how this only has one thing in the denominator? And this has two things in the denominator, because if I end up with a radical over here in the denominator, I don't want to do that, do I? No, I don't want to have to rationalize by multiplying by the conjugate. Okay, I don't want to have to do that. So we're using 45, right? So I know I'm going to end up with the radical because it's rad 2 over 2. So I'm going to choose either one of these that I think is going to be easier. The easier one's going to be this one here, because I know I have a radical, and so I can only multiply by one thing here. If I have two things, I have to multiply by the conjugate, which makes more work. And I don't want a radical inside a radical. A little bit of sense? I think when we actually do the work, you'll realize which one. So when I do this one, I'm going to use this one right here. So 1 minus cosine over sine. So 1 minus cosine of A over sine of A. What is my A value in this case? 45. 45. So that's a pretty easy one. It's in quadrant 1. So this is going to be 1 minus rad 2 over 2 divided by rad 2 over 2. I am going to multiply by the conjugate here, or not the conjugate, the reciprocal. Yeah, but if I had 2 terms, I would need the conjugate. But I don't want to do that. So I know I have 1 term on the bottom, so I can multiply by the reciprocal. So this turns into, parentheses, 1 minus rad 2 over 2 times, what is the reciprocal of the bottom? 2 over rad 2.
But you can't have that.
I can, but when I'm done, I have to clean it.
Oh, okay, so you don't do it.
Don't do it right away. So I have to distribute it. So as it comes out here, that gives me, so 2 over rad 2. 2 over rad 2. Over here, I come up with, so that's going to give me just minus 1, isn't it?
Yeah.
Okay.
Why are we doing it red now?
I know.
Okay. You want black?
Yeah, it makes me.
I feel like, yeah, you're
Okay.
doing something different.
Okay, so now since I changed colors, I have the step right here. All right, so now 1. What's my common denominator here? It's rad 2, isn't it? There's only 1 denominator in this case, and it is rad 2. So from here, it's going to be 2 over rad 2 minus rad 2 over rad 2.
That'd be 2
Yeah, okay, so I did some magic right here. Did you guys all catch that?
No.
Okay, 1 right here, right? This 1 needs to have a common denominator of rad 2.
So it's bad.
But if I put rad 2 divided by rad 2, if I divide that, don't I still get 1? Yeah, it's the same. It's equivalent right there. So that's what I'm looking for. So that's the same. So I needed that. So I got that. So it's going to give me 2 minus rad 2 over rad 2.
And then do the red cancel out or no?
No.
Why not?
Because this is a binomial. There's 2 terms. I cannot cancel anything unless I can cancel the whole thing.
Okay.
So this, I have a radical in the denominator, but I planned this out. So now I only have 1 term in the denominator. So it's not a 1 plus rad 2 or 1 minus rad 2. It's only just rad 2. So to rationalize this, I just multiply top and bottom by rad 2. Very good. So I multiply top and bottom by rationalizing rad 2 over rad 2.
And then rad 2 times rad 2 is equals to.
Very good. So on top, as I distribute, it's going to give me 2 rad 2. And then when I distribute here, it's going to be minus 2, right? Minus, yes, very good, over 2.
So many 2s.
2.
I know.
And it's
Oh,
Tuesday.
it's,
Sorry.
someone's punny.
Yeah.
All right. That joke was pungent. All right.
No.
So now, if you notice, now they all have 2's, don't they? Now, I'm going to show you how to actually do that if they all have the same factor. So I could take a 2 out of the top.
Yes.
So this is how you actually cancel from both. So if I could factor a 2 from the top,
Are we able to just leave it like that?
no. There's a reason. I'm trying to get you guys to the point where on a multiple choice test, which we will be having, okay, you have to be able to identify what the answer is. So the answer is going to be simplified. And so what you need to do is actually be able to simplify this. So we took out a 2. So what's left here? Rad 2 minus 1. Very good. So 2 divided by 2 is 1, right? 1. I said 1. I still wrote a 2.
Are we
All over.
2 out the whole thing or just the top?
Just the top.
Got it.
Just the top. Because this is how I could take something out of the top.
And then those 2's cancel out.
Yes.
Right? Cool.
If the 2 is in front multiplying here, multiplying by all of that, then I could cancel it out with the 2 on the bottom. That's dividing all that.
Oh,
So So this multiplication and division go away. So I'm left with my final answer of just rad 2 minus 1. There.
So are we just simplifying this?
Yes. This is a lot of algebra and simplification. Yes, go ahead.
Wait, no, on our covenant.
Why did you put the 2 on the bottom again if you had already like
I took it out here. I only took this out of the numerator. So I took it out of the numerator, but the denominator stayed. So the denominator stayed. I needed it to be there to show that if I took it out of the numerator, I have a 2 there, right? And the 2 that was in the denominator, this 2 is multiplying by all of this, where this 2 right here is dividing by all of this. So we have all of this being divided by 2, which gives me, this, but then I also have it multiplied by 2. So the 2 that's multiplying and dividing at the same time is going to cancel out. A little bit better?
Working?
Yes. Kind of.
Yes or no?
For the time being. All right. So, questions?
You made him walk back there.
Are we okay? Okay, so I'm going to leave you guys with the first 2 examples, and tomorrow we're going to pick up the rest.
Are you gonna give us
Did we get homework?
Yes.
But not the notes.
It's homework's right there. I'm passing it out here momentarily.
Oh, I didn't. Oh.
All right, don't forget, like and subscribe.